Hi everyone, welcome back. The learning goal for this video is to identify the states and the physical and chemical properties of matter. And what you're seeing here is an example of seawater being evaporated, and it's given off solid crystals of salt, which is sodium chloride. And sodium chloride is an example of a solid. So let's go over the definition of solids. They have definite shape, definite volume. They're particles that are close together in a fixed arrangement. And the particles move very slowly. And so once again, a solid has a definite shape and volume. And this is an example of amethyst, which is a solid. It is a purple form of quartz, which is made of silicon dioxide. So solids are a state of matter. We also have liquids. Liquids have indefinite shape, but a definite volume. So they take the shape of their containers. So you can see this glass of water is taking the shape of these different containers. The particles are close together, but they move around a little bit more. This is an example of a space filling model of water. So it represents a water molecule, and water is H2O. And when we look at space filling models in chemistry, oxygens are typically represented in red, hydrogens are white, carbons will be black. And so these are representing the water molecules. You can see they're close together, but they have a little bit of space to move around. The particles still move slowly, not as slow as if they were in a solid state of matter. And once again, a liquid has a definite volume, but takes the shape of its container. And the final state of matter we'll be working with are gases. And gases have indefinite shape and indefinite volume. They have the same shape and volume as their container. So we have to, for example, in this balloon, enclose the gas particles inside there. Now you can see here, these gas particles, these are representing helium inside the balloons. They're really far apart. And you can see kind of the shadow there that's trying to represent the fact that these particles are moving quickly, very fast. So once again, a gas takes the shape of the volume of its container. So let's look at a summary together. And so this table compares solids, liquids, and gases based on different characteristics: shape, volume, arrangement of particles, interaction between particles, which we will talk about in more depth later on in our class, the movement of particles and different types of examples. So for example, solid, once again, has a definite shape and volume. The arrangement of the particles are very close together and fixed. There's a very strong attraction between those particles. They move very slowly, and some examples are ice, salt, and iron. Liquids take the shape of their container, but still have a definite volume. The arrangement of the particles, they're random, but they're still close together. They have a strong attraction between particles. It's moderate movement, and some examples are water, oil, and vinegar. Gases take the shape of the container and also fill the volume of the container. The particles are random and very far apart. We will assume that there's essentially no interaction between the particles, so no attraction. And they move very fast, and some examples are water vapor, helium, and air. So let's go ahead, pause the video, try the study check on your own, and then come back and check your work with me. All right, so we're asked to identify each description as that of a solid, liquid, or gas. And this is going to help us in the laboratory when we're working with different types of matter. So part A, it has definite volume but takes the shape of the container. Good, it's a liquid. Its particles are moving rapidly. What did you put for that one? Excellent. It is a gas. Its particles fill the entire volume of a container. What did you put for that state of matter? Good. It's a gas. Its particles have a fixed arrangement. What did you put for that one? Good. That's a solid. Its particles are close together, but moving randomly. Excellent. Yes, it's a liquid. All right, pause the video again and try the study check on your own, and then come back and check your work with me. All right, so let's check your work. Identify the state of matter for each of the following. Vitamin tablets. Good, it's a solid. Eye drops. Excellent, that's a liquid. What about vegetable oil? Also a liquid. A candle. Solid. Air and a tire. Very good, that's a gas. And so when you're working with different types of matter in the chemistry laboratory, or wherever you're working, you are already classifying different types of matter as solids, liquids, and gases. All right, now let's discuss properties. The first type of property we will discuss is physical properties. Now, physical properties are characteristics observed or measured without changing the identity of a substance. I'm going to repeat that again. Physical properties are characteristics observed or measured without changing the identity of the substance. So we are not changing the identity, and that's really important to recognize that you can distinguish between physical and chemical properties later on. So what are some examples of physical properties? Well, that includes shape, physical state, boiling and freezing points, density and color of a substance. So once again, you're not changing the identity of a substance. So for example, I love to cook. And so I am always constantly boiling water to make, for example, pasta. And to do that, I first take the water, and at room temperature, water is a liquid. So I'm representing that as L there, cursive L. And then when I turn my stove on, I'm adding heat energy. And then those water molecules, we'll learn a lot about this later on, but those water molecules get excited, and then they start to go from a liquid to gas. So as the water starts boiling, more of the water molecules in the liquid phase turn into a gas. And so notice how the identity of the substance hasn't changed. Water is still H2O. Its identity has not changed one bit. The only thing that changed was its physical state. So this would be an example of boiling water as a physical property. And that will be a core chemistry skill that you develop in my class, is identifying physical and chemical changes. Let's look at another example for physical properties. So once again, my love for cooking. Copper is a great material to cook with because it is a good conductor of heat. And we'll talk more about that in later videos. But for right now, we can make some observations about the physical properties of copper. Copper is reddish and orange in color, as you can see here. It's shiny. I've just told you it's an excellent conductor of heat and electricity, which we'll learn more about later on. It is a solid at room temperature. So anytime you see 25 degrees Celsius, that's room temperature. If we looked up its melting point, it would be listed as 1083 degrees Celsius, and its boiling point is 2567 degrees Celsius. So these are all physical properties of copper. Now let's discuss a physical change, which I kind of gave you an example of earlier when I talked about boiling the water to make pasta. So a physical change occurs In a substance, if there is a change in the state of matter, so when I said water went from a liquid to a gas, that counts as a change in state. If there's a change in the physical shape, if there's no change in the identity and composition of the substance, once again, if you're working with water, it stays as water. Now, as you see here in our earlier example that we saw on the first slide in the video, we see these seawater beds here, and slowly the water is evaporating. So it's going from a liquid to a gas. And as it does, what's also in the water is sodium chloride. And we can see the sodium chloride at the edges of these water beds here. And nothing's changing chemically to sodium chloride. What we will learn is that originally sodium chloride was dissolved into water. And then eventually, after the water evaporates, we are left with solid sodium chloride. So sodium chloride is still, the same identity. S stands for solid. And what we will learn is that AQ stands for aqueous, which means it is dissolved in water. But once again, the evaporation of the seawater did not change the identity of the water, did not change the identity of the salts. And so therefore, this is just a physical change taking place, even though there's two different substances that are present in this solution. So let's go through a few more examples of physical changes. Like I said already, water boils to form water vapor. Vapor just means water as a gas. Another example is sugar dissolving in water to form a solution. So for example, if you like iced coffee, you may want to put simple syrup in it. Simple syrup is just sugar dissolved in water at maybe a higher temperature, so it goes into solution. Copper is drawn into thin copper wires. And so for example, we'll learn a lot about metals and how they're malleable. And so copper can be drawn into thin copper wires. And remember that copper is a good conductor of electricity. But this, just changing it, the shape of it doesn't change its identity. So this is a physical change. Paper is cut into tiny pieces of confetti. Once again, the identity of the paper is not changing. We're just changing the shape. And pepper is ground into flakes. Once again, not changing the identity of the pepper, just changing the shape. So go ahead and pause the video, try the study check on your own, and then come back and check your work with me. All right, we were asked to classify each of the following as a change of state or change of shape. So chopping a log into kindling wood. What did you say? Excellent. It's just a change of shape. Water boiling in a pot. Good. That's change of state. Because water is going from a liquid to a gas. And so the key word that told us that was boiling. Ice cream melting. Good, that's a change of state. Ice cream's going from a solid to a liquid. And the key word that told us that was taking place is melting. Ice forming in a freezer. Excellent. That's also change of state. So when we put, for example, our ice cube tray in the freezer, initially the water is a liquid, but then eventually it turns solid. So that's the change of state. And then finally, cutting dough into strips. Okay, that's just a change of shape. Nothing else is taking place with the dough. We're not baking it yet. We're just cutting it into strips. So we're just changing the shape. All right, now we have a better understanding of physical properties and changes. Now let's look into chemical properties and changes. Chemical properties describe the ability of a substance to interact with other substances and also to change into a new substance. When a chemical change takes place, the original substance is turned into one or more new substances with new chemical and physical properties. This is exciting for me as a chemist. This is where the chemistry takes place. So for example, can't help but bring in my love for cooking here. As you can see here, this is flan, and flan has a topping of caramelized sugar. And to make this caramelized sugar, we have to heat sugar at high temperatures. And be careful to not overheat it because you don't want that burnt caramel. You want it just right. But that is an example of a chemical change. The new substance forms has a new composition, it has new chemical properties, it has new physical properties. And maybe in this case, it just tastes better. Let's go through a few more examples of chemical changes. So for example, if you have silver, like actual silverware made of silver, originally that silver metal is shiny, but over time it reacts with the oxygen in air to give a black grainy coating. Same if you have like pure silver jewelry. That is an example of a chemical change. You're actually forming something called silver oxide, which we'll learn more about later. If you ever like to go camping and you make a fire to cook your food, a piece of wood burns with a bright flame and produces the heat to help cook our food and keep us warm. It also produces ashes, carbon dioxide, and water vapor. We will learn later on that this reaction is a combustion reaction, and it is a chemical change taking place. That wood is changed into carbon dioxide, water, and ashes. Heating white granular sugar forms a smooth caramel color substance. So like we saw in the flan example earlier, we didn't just sprinkle sugar on it. It'd be different. It'd be a different texture. It would add the sweetness. But what we did first was we heated that sugar to form that caramel sauce to pour on top of the flan. It tastes really good that way. And that's a chemical change that's taking place to form the caramel from the original white granular sugar. Iron metal, which is gray and shiny, combines with oxygen to form orange-red rust. So if you ever see a rusty nail, what's happened to the iron metal is that it's reacted once again with air. That's oxidation. It's reacted with oxygen in the air to form iron oxide, which is that orange-red rust color. All right, so go ahead, pause the video, try the study check on your own, and then come check your work with me when you're done. Okay, let's classify each of the following properties as physical or chemical. And this is going to help us in the laboratory when we are writing observations on when we do different experiments together. So ice melts in the sun. Would you classify that as physical or chemical? Good, that's a physical change or physical property because the ice is just melting, right? That keyword melting implies that it's only going from a solid to liquid. We are not changing the identity of the ice. Copper is a shiny metal. That's also a physical property. We're just describing it. And you'll make lots of different observations of physical properties when you work with different substances in the lab. Paper can burn. Good, that's a chemical property. Once again, we will learn that burning paper or wood or natural gas, for example, will be a combustion reaction. And we'll learn that What you start with changes its identity. You end up with carbon dioxide and water in the end. A silver knife can tarnish. That's also a chemical property. So just like I said earlier, the silver metal reacts with oxygen in the air, and it's called oxidation. And it's going to form something different, kind of, that tarnished color, which is actually silver oxide. A magnet removes iron particles from a mixture. That's a physical property or physical change there. We're not changing the identity of the iron nor the magnet. We're just using the magnet to remove iron particles from a mixture. So that's physical. All right, go ahead and pause the video again. Try the study check on your own, and then check your work with me when you're done. All right, let's classify each of the following changes as physical or chemical. Burning a candle, what did you say for that one? Good, that's a chemical change. We are changing the identity of the candle, and even as you're melting it, you probably smell some of the, if it's a scented candle, you might smell some of those compounds that are coming off of it. There's definitely the identity of the candle is changing as you're burning it. Ice melting on the street, what did you say for that one? That's physical, good. See that word melting again, we're changing the state of matter, but not the identity of the ice. Toasting a marshmallow, good, that's chemical. As you can see, a lot of what we do in the kitchen when we cook our food are chemical reactions, and I will give those examples throughout our time together. Cutting a pizza, good, that's physical. We're not changing the identity of the pizza, we're just cutting it. So changing the shape there, that's a physical change. And what about iron rusting in an old car? Good, now I'm hoping you're hearing the word rust and understanding that that's actually a chemical change. That's the iron metal reacting with oxygen in the air to form iron oxide, which in the end is rust. All right, thank you for watching. And as always, email me with any questions.